All right, good morning. It's 9:30, so we'll go ahead and get started. All right, so this is the first Zoom session we're having for this fall semester for CMIS 102. Usually I'll conduct these about every week. There may be weeks where I don't, but for the most part, we'll do them every week. And what I like to cover material from the course, but also talk about the assignment that you have due coming up. These sessions are recorded, so if you miss something or you didn't quite understand something, you can always go back at a later time and review the videos, and I'll get the links posted for those in the course announcements. If at any time you don't understand what I'm going over at that moment, you can also go ahead and either put a question in the chat box, or you can unmute yourself and go ahead and ask the question at any time. But at the end, I will also set aside some time specifically for questions and answers. All right, so let's go ahead and get started. So this course is about Python. It's about your basic level programming in Python. So we'll go down this list of stuff from the material this week. So in all programming languages, not just Python, we have this concept of a variable. A variable is a placeholder for a value that you don't know what it is yet. So for example, if you have some numbers, if you have number 10, 11, 12, 13, whatever the case is, but when you implement your program, you don't know that's what the number is going to be. So you can use a placeholder called what we call a variable. So for example, we'll say A equals 5. Okay, that means the variable is A. It's just like, if you can remember from, I don't remember if it was middle or high school, when you do, what's it called? Not calculus, algebra, right? I think it's algebra. When you have variables and x plus y equals z and, things like that, it's similar in programming languages. So we have this variable A, and we're going to say A is equal to the value 5. Okay. Now your variable name, it can be really anything you want with a couple of rules. Your variable must start with a letter. It could be uppercase, it could be lowercase. It can contain numbers, but it cannot contain like special characters, like an asterisk or a $sign or things like that. So let's list out some valid variable names. A is okay. Capital A is okay. And I want to note that capital A is different than uppercase A. So these are two different variables. You can have B, 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 B. You can have this as a variable. You can have that as a variable, this as a variable, and that's all fine. You cannot have a variable that starts with a number. You cannot do that. You cannot have a variable that has a special character in it, like these $signs. You cannot have that. Okay. So your variable must start with a letter, but it can contain numbers. It doesn't have to contain numbers, but it can contain numbers. And it can be uppercase and lowercase letters, and that's fine. And just remember, Bob is different from this Bob, is different from that Bob, is different from that Bob. Those are 4 different variables. Okay. Let's go back. So I have a variable, I'll just call it AAAA, and I'm going to say it is equal to the value 5. So now whenever I want to reference AAA at a future point in my program, it has the value 5 in it. And let's show some things we can do with variables. First of all, we'll talk about what print does. You should have seen print so far in your reading materials and practice. But here in print, we can put what we want to print. Let's save it, and we're going to run it. What's going to happen here? It's going to print out exactly what's inside of these quote marks, right? So if we look at it, we run it, and it prints out what we want to print. Okay. You can put numbers in here, put the number 15, save it, run it, and it prints out the number 15. Well, what if we didn't know when we programmed that the value was 15? What if we wanted to use a variable? Let's say we have the variable AAA, and it's going to be 15. Now here, we can print out the variable. So because we said this variable is equal to the value 15, now when we print this variable, it'll give us the value 15. Save it and run it. There you go, it prints out 15. And here we can change this to whatever we want. 268, and save it and run it. And you can see that variable is now equal to the value 268, because that's where we changed it. Now, a variable doesn't have to be a number, it can be a string. This variable is a string. And we denote it as a string by having these beginning and ending quote marks. You can use single quotes or you can use double quotes. Either one is fine as long as they match. If you use double quote on this end, you have to use double quote on this end. If you use single quote, it has to be single on both ends. I personally prefer single quote, but if you use double quote, there's nothing wrong with that. So let's save it and run this. And what's it going to print? It's going to print this variable is a string. Okay. So that's what a variable is. And you can have as many variables as you want in your program. This is another string, right? So let's print the first one, and then we'll print the second one. Let's differentiate them more so it's easier to see. There we go. So we're going to say AAA. A is this variable is a string. The B's, this is another string, and then we're going to print them. And you'll see it says this variable is a string, and this is another string. Likewise, it can be two separate numbers. Save it and run it. And 13 and 19. They can be, one can be a number, one can be a string. That's fine. Oops. Okay. I accidentally put a slash mark in there. There we go. Okay. So that's what a variable is. It's a placeholder. It's a placeholder for a future value that you don't know yet. Okay. So let's talk about what a type is. Each variable has a type associated with it. And what I mean by type is it a string? Is it an integer? Is it a floating point number? Is it a list? Is it a map or a dictionary? The map and dictionary we'll get to in future lessons. Right now, we're really dealing with strings, integers, and floats. Okay, so what's the difference between them? Okay, so let's just deal with an AA variable. We're going to say AA is equal to 13, right? And of course, if we print out AA, it should give us 13, right? Save it, we run it, there we go, we get 13. But what is the type of 13? What is 13? 13 is a number, right? But we really have two different kinds of numbers in Python. We have integer, which is just whole numbers, and we have float, which is any number with a decimal point in it. Okay. So if we can print out AA, we can also print out what we call the type of AA. Notice I'm saying the type of AA is what I want to print out. Let's save it and let's run it. And you can see we print out 13, which is the value. And then when we print out the type of AA, you see right here, it's an int, meaning it is an integer. It is a whole number. What if we change this to a floating point number? See, we have a decimal in here now. So now let's print it out. And it tells us that variable is a float because it has a decimal point in it. What if I have this 3.0? What's going to happen here? It's still going to be a float. Even though we don't have anything after the decimal place, it's just 0. I have still defined it as a float because I put 0.0. If I put it without it, if I just put 3 with no decimal, it tells me it's an int. But if I put 0.0, it tells me it's a float. And of course, we can also have it as a string. This is a string. And when we run that, it tells us the type is str, which is string. Okay. So that's what we mean by what is the type of it. And really, the only three you need to worry about right now are integers, floats, and strings. And that's how you can tell what type it is by using this type command right there. Okay. So that's all great, but what, how do we make a program? How do we do some kind of computation, right? So we have this concept of what we call operators. And it's just like you would think your normal math operators are. We have addition, subtraction. Actually, let's make a comment. We have addition. We have subtraction. We have multiplication. We have division. We have modulus. Most people probably don't know what modulus is, but we'll cover it. We have modulus. And then we have, this always tricks everybody up, integer division. And we'll discuss what the difference between integer division and normal division is. We'll talk about those. So let's take them one at a time. So first, let's put that comment at the top. So if you haven't seen yet, whenever we use the hashtag, whatever we put after that means it's a comment, meaning it is not code that the computer actually runs. It's just text that we put in the file to help the programmer remember something, to help the programmer understand why we coded something a specific way. For me, I'm putting these comments in here at the top just so I can show you and help remind you what each of these operators does. It's plus, minus, multiply, divide, modulus, and integer division. So let's start tackling them one at a time. So let's start with the addition. Let's say we have a variable a, and we say it has the value 5. We have a variable b with the value 13. We can have the let me do this as 20 and 9. Start like that. Now we can have c is equal to, we can describe a mathematical formula that we want c to be the result of. So for right now, let's take the first one and let's do addition. I can say a plus b. And then if we print out c, what are we going to get? We should get 29, right? We run it, and there enough, we get 29. So we have used these variables to do some kind of mathematical operation. I can change this. I can make this 11. Save it and run it. And now the answer is 31, right? So that's easy enough. That's addition. That's elementary school type stuff. Addition. Okay. Let's do subtraction. Do subtraction, save it. Of course, it's going to give us the right answer. The answer is 9. 20 minus 11 is indeed 9, right? And you could do b minus a. The order of them doesn't matter, and it'll do the appropriate math operation for you. That's -9. Okay, that's fine. Addition, subtraction, and addition, subtraction, multiplication, all very easy, just like you've been doing in grade school forever. Let's say, now we'll do the multiplication. B times a is what, 220, I think. Yep, 220. That's how we can do multiplication. And it doesn't just have to be with variables. I could have put 5 times 7 there. I could have put numbers directly in there. And what's 5 times 7? 35? Yep, we run it as 35. but I was just using my variables that represent values. I can have a times 10. So I can mix a variable with a number, and that's fine. That's 200. Let's stick with our a times b. Okay, let's do division. Let's do a divided by b. And what are we going to get here? 20 divided by 11 is 1 point something. Let's run it. And that's the answer, 1.81 repeating. Okay, so that's division. Pretty simple, nothing surprising there. Okay. Let's repeat these real fast with floating point numbers. As we saw here, these were integers, right? Because there's no decimal point. Well, let's repeat them with decimals, say 20.5 and 11.4. Let's do plus. So we'll do a bunch of them. Do all of them together. Do plus, then minus, then multiply, and then divide. Let's run it. You can see here, this is a plus b, this is a minus b, a times b, and a divided by b. Okay, so it works the same whether you're using floats or ints. Show you again with integers. We run it, and there we go. There's the answers when they're integers. And of course, if we put the point zeros here, it still works fine because really those are floats. You can see the answers there. Okay. So let's talk about the two that you're probably not familiar with, which is modulus and integer division. Let's get rid of all these extra things. So let's do C is equal to A modulus B. And really, this modulus and the integer division, they kind of go hand in hand, and you'll see why here shortly. So A modulus B. These two are meant for integer numbers. You can use them with floats, but they're not going to give you the answers you think you're going to get. It's really kind of undefined a little bit. So if you're doing modulus and integer division, you need to do it with integers. Okay, so A is an integer, B is an integer because they don't have a decimal point. So I'm saying A modulus B. What this does, it will give you the remainder. You remember back in middle school or whatever, we were doing long division and you get the remainder, right? So what is the remainder of 20 divided by 11? I think it's 9, right? So if you divide 20 by 11, you get 1 remainder 9. I think that's right. So when we print this out, we get 9 as the answer because this modulus operator gives us the remainder. So if we change this like 15, the remainder should be 5, right? And sure enough, the answer is 5. So that's what the modulus does. It does the division of these numbers, but it gives you the remainder as the answer. Right? So now let's talk about the difference between division and integer division. So what I did here real fast, I'm saying C is the normal division, D is the integer division, and then I'm going to print out C and D. Save it. Let's run it. And why are we getting different answers? This is the normal division, and this is the integer division. Just the one. What integer division does, it does the division, but it throws away the decimal point. It only gives you the whole number back as an answer. That's why you see with normal division, I get 1.3333, etc. And for integer division, I only keep the whole number. Let's say if I make this a really big number, 20,000 divided by 192, whatever. Save it and run it. That is the normal division. And for integer integer division, I only keep the whole number. Okay, so that's the difference between normal division and integer division. Okay, and that's pretty much all of our operators. Oh yeah, we do have another one. We have star star, which is the power. Sorry, I forgot that one. So if we say C equals A star star B, let's put them in manageable numbers. Let's say 2, 3, and then print C. I think this should give us 8, and it does. The answer is 8. And that's because we're taking 2 raised to the 3rd power. And we can put 5 to the 3rd power. I think that's 125. Yep, 125. We can put 3 to the 5th power. And I don't know what that is off the top of my head. It's 243. Okay. So star star means raise it to the power of. And note, it has to be star star like together. You can't star space star is going to give me an error. Yep. It tells you there's an error and it shows you exactly where the error is. So it has to be, the star star has to be consecutive. Likewise, the slash slash for integer division also has to be consecutive. You can't have a space in there. You can have a space between the variables, but you don't have to. So if I do that with the variables beside the operator, that's fine. It's very good practice though to have space separation, just because it makes it more readable. All right. So that's all the operators you really need to be concerned with for numbers. What about strings? So let's say A was hello and B is world. If we add them together, what are we going to get? A is hello and B is world. If I add those together, what do I get? We get the strings, what we call concatenated. That just means we take the two strings and mash them into one string. That's what the plus does if you use it on strings. What happens if we have a minus? It actually gives an error. And why would it give an error? Well, you know, conceptually, you can think about plus being to where you put two strings together. You know, that kind of makes sense. But how would you extend that thinking for a minus sign? That there really isn't a good way conceptually to think about subtracting strings, and we can't. So if you try to subtract strings, it's going to tell you it can't do it. It's going to tell you it can't subtract a string in a string. Likewise, we can't divide strings. Error. And so on and so forth. We can't multiply strings. We can't do string powers or anything like that, because it just doesn't make sense to be able to subtract or multiply strings, right? But as I said, you can add strings. Can you add a string and a number? You can't. It doesn't make sense to add a string and a number. A string is just some characters, and a number is a value, right? It's a numerical value, and it just doesn't make sense to be able to add those together. However, let's make this a star. You can multiply a string and a number, and this is really just a Python shortcut, and this is what it gives us. So when you take a string and you multiply it by a number, it will just repeat that string that many times. So here I had like asterisk, but you could have multiple characters. If I run this, as you can see, it'll just repeat that string that many times. So if we put this as 3, that string 3 times, you can see I have that string repeated 3 times. So you can multiply a string with an integer. You can't do it with a float. You can't do that, but you can multiply a string with an integer, and it will just repeat the string that many times. All right, so that's your operators on integers, on floats, and on strings. Okay. So let's dive a little bit more into a string and an integer or a float. What is a string and what is a number? Okay. So if we have A as 10 and B equals that, are those the same thing? So is string 10 the same thing as number 10? The answer is no, they are not. One is just alphanumeric characters, right? This isn't the number 10. It may look like the number 10, but this variable is not the number 10. It is a string that looks like the number 10, but it is not the number 10. This variable B, it actually is the number 10. Right? So when we try to do B plus 5, excuse me, let's try to do A plus 5 and then print C. What's going to happen here? This is going to give us an error, right? Because we're trying to take the string 10 and add it to the number 5. And of course, we get an error. I've already said you can't add a string and a number together. However, B plus 5, that's perfectly valid, 15, because B is a number, A is a string. You have to make sure you understand the difference between the string representation of a number and an actual number. Those are two different things there. All right. Only one more thing to cover for the material, and then I'll talk a minute about your assignment, and then we'll do some questions. All right, so the last thing is getting user input from the keyboard. All right, so you saw we had things like this, A plus B, and then print C, right? If we run that, we get 13 or 12 is the answer, right? Yep, this isn't very useful if we're just already assigning the values, because the only thing this computer will, the only thing this program will ever do is print out the value 12, right? Because I've what we call hard coded in here the values. When I say we hard coded in a value, that means when we make a variable, we're telling it explicitly what the value of that variable is. That's what you call hard coding a value. All right. So since we have hard coded these values, the only thing it can ever be is 12, unless we go in here and we change the program. If we go in there and change the program, of course, we can get something else, right? But let's say we want the user to tell us what numbers to add together. We want the user to tell us what numbers to add together. We get that as input from the user. In Python, we do that. We say input. Inside of here, we put what the user prompt is. And what I mean by prompt is what is displayed to the user to tell them what to do. So inside of here, I'm going to put, please enter a number. Let's just leave it at that right now. So I'm going to say input, please enter a number. And then for right now, I'm just going to print out what the number is. I'm going to print out that A. All right, let's run that. As you see, it's now stopped and asked me, please enter a number. And now my cursor's right there blinking. It's waiting for me to do something. What should I do? Well, it tells me to enter a number. So let's enter a number, 1, 2, 3. And then it tells me, it printed out A, it prints out 1, 2, 3. So that's great. That allows me to put into a variable what the user typed in. So if you think a second ago when we were adding two values together, I could ask the user for two values. I could say, please enter a number, and it's going to save that in A. I could say, please enter another number and save that in B. And then we'll just print out A and B. So let's run that. Please enter a number, 1, 2. Please enter another number, 2, 3. And then as you can see, I print out A, which is 12, which is what I typed in. And then print out B, which is 23, which is what I typed in. So I've got input from the user, and I've saved it in a variable, and now I can do something with that. But there's a catch. There's always a catch, right? What is the type of A? You know, we just went through describing, you know, the different operators, plus, subtract, multiply, etc. And we discussed about you know, how you can add strings together, if you can add strings and numbers together, you know, doing the operators with numbers, doing them with strings. There's different rules, right? So depending on the type, depending on if it's an integer, if it's a float, or it's a string. So what is the type of A? Can we just add A plus B? Can we do that? Can we subtract them? And it depends on what the type of A and B is. So instead of just printing out A, let's print out the type of A, and we'll print out the type of B. So let's have Python tell us what is the type of A and what is the type of B, right? So if you run it, so let's say please enter a number. Let's say I messed up and I put in QWERTY, and for another number, this, it's going to tell me A is a string and B is a string. Okay, so let's say I wanted to do subtraction. Oops. Can I do that? Print. What happens if I do this? And if I still type in something wrong, you know, my program crashes, right? Because A is a string, and A is a string, B is a string, and you can't subtract strings, right? Even if I just wanted to add instead of subtract, I can add strings together, as we discussed. But when I add strings together, it just concatenates them side by side. If I did QWERTY and I did this, you know, it just concatenates the strings side by side. Right. So let's go back to subtract. So instead of QWERTY and whatever, let's type in actual numbers. Let's type in 12 and 23. And I'm still getting the error. And why am I getting this error? It's telling me it can't subtract two strings. It is saying A is a string and B is a string. And why is that? I typed in the number 12. I typed in the number 23. So why is it saying they're strings? It's saying they're strings because input, it always gives you a string in return. So no matter what I type in for input, if I type in a number, if I type in letters, if I type in a smiley face, whatever I type in, it's going to give it to me as a string. So A will always be a string. Whatever input gives me is always a string. So then, how do I do the subtraction, the multiplication, and so on and so forth with that if it's a string, right? Well, we have this other concept. We can do this right here. Int, put that around the whole thing. So what's happening here? So the input will give us a string. The int, with that input inside of it, it will take that string and convert it to an integer number for us. When I run this, enter a number, 1, 2, 3, enter another number, that, well, I typed in a string. So now A is of type integer, and that's because I put the integer here at the beginning of it. B, it's still a string. Even if I type in a number, B is still a string, and that's because I haven't put the integer there. If I put the int there, now they are both integers, and I can do that subtraction when they're both integers. If I run it, there you go. It works fine now because A is an integer now and B is an integer now. What happens if I type in letters now, though? So when it's asking me, please enter a number, what if I type in QWERTY? You know, my program is going to try to take that string QWERTY and convert it to an integer. Can I convert QWERTY to an integer? No, that doesn't make sense, right? So when I try to do this, it's going to crash on me. And that's because Python doesn't understand, and nobody can convert the string QWERTY into a number, right? It just doesn't make sense. We can convert the string 1, 2, 3 and 3, 4, 5. Those convert into numbers because that is the string of a number. But when it is the string of something that is not a number, it crashes. That's mostly for your information. For this class, whenever you're doing your programming, I don't need you to worry about this too much, right? You can go ahead and always assume the user is going to type in the right thing. In the real world, that's not going to be the case. In the real world, you want to do a lot of what we call error checking. So before you try to convert the integer, you got to do some checks to make sure what they typed in is actually an integer. We're not going to worry about it for this class, but going on in future careers, that is a thing. Because if a user types in the wrong thing, and honestly, how many times have you typed in the wrong thing? If a user types in the wrong thing, we don't want to crash the whole program, right? We probably just want to tell them, hey, you typed in something wrong. Worry about that for your future career. Don't have to worry about it so much for this class. Just know that when we put the integer here, it takes this string and converts it to an integer. Likewise, we can have it, we can do float. Actually, let me show you that real fast. So what if we type in a float number? Again, it's going to crash as well because we can't take this and convert it to an integer. It's a float, but we can put float here, make both of them floating point numbers. And that works fine. And it tells you, A is of type float and B is of type float. So that's how you can get input from the user. You save that input into a variable. You do some kind of math computation with the variable, and then you print out what the value of that variable is. And we don't just have to print out C, we can print out the answer is. We could do that to make it a little bit more nice. Let's make these back to integers. Save it and we run it. There we go. A is still an integer, B is an integer, and the answer is 11, or answer is -11 because we did the subtraction there. Of course, it doesn't just have to be subtraction, it can be powers. So 12 to the power of 34 is that really long number answer. Okay, so let's take a second to talk about your assignment. There's really nothing in the assignment that I haven't already given you an example of this morning. So for your assignment, you should prompt the user for the number of hours worked and the weekly sales. Right here, I have prompted the user to input a number and input another number. You probably need to prompt the user to input the number of work hours and input the number of weekly sales, right? You don't need to print out these types. Then you need to do some kind of mathematical formula to compute what the person's pay should be. I'm not going to do the formula for you. You got to figure out the formula, but you need to take their input, compute some kind of mathematical formula to compute their pay, and then you need to print out their pay. That's all there is to your first assignment. One last thing I want to mention about variables, and then we'll open up for questions, is, you know, A and B and C, they're not very descriptive, right? Yeah, at the beginning when I was talking about variables, you know, a variable can be really as long as you want it to be. You know, that can be your variable. That's also not very descriptive, so it doesn't help too much. But when you name your variables, you want to describe what they're used for. So maybe I want to name this one first number, name that one second number. Then I could say C is the math result of the first number times the second number. That's much more descriptive, right? You know, for this short program that's only like 5 lines long, yeah, I mean, you could probably just use A and B and it would be fine because it's only 5 lines long. It's not hard to read, right? But imagine you have a program that has 10 million lines of code in it. And these big programs have millions of lines of code in it. If you have millions of lines of code, if randomly in that file somewhere you just have A equals this, B equals that, it's not very descriptive. So when you go back and you have to find a bug in your program and you have to fix that bug in your program 2 years later, when you come and look at this program 2 years later, you know, if you're just using A and B and C, it's going to be really hard to remember what it did. What was the purpose of it, right? So you always want to use descriptive variable names along with comments. So you see, I have these comments up here. You also want to have comments in here that remind you what you did 2 years later. So for this, have the user input the first number. Let's make another comment. Have the user input the second number. Third comment, perform sub or multiplication on the 2 input numbers. Display result of the multiplication. That's how you should be using your comments. You could probably get away with just having one for the first. We could just have the user input 2 numbers. You know, we can cut down on the comments a little bit like that, right? And that's acceptable. But you do have to comment your code. And part of your grade is commenting your code to say, you know, in just plain English terms, what you're doing. And then you'll have the Python code. And then plain English, what you're doing, and then the Python code, and so on and so forth. That's your comments. All right, that's all there is to week 1. Excuse me, that was week 2. This is all you need to know for your first assignment. And I'll go ahead and open it up for questions. Is it?
Can you hear me?
Yep.
All right, Professor, are you able to go on creating a function and calling off that function?
If you stay on after this, I will. I don't want to get too far ahead of that right now because that's further on in the class, and I don't want to kind of confuse people for the first week type stuff. But if you want to stay on after I go through the rest of the questions, I'll show you how to do that.
All right, cool. Thanks.
Good morning, Professor. Can you hear me?
Yes.
Hi, so my name is Randy. I just had a quick question. During our readings, whoever the instructor is, he always uses the eval function. I was wondering if you're possibly able to explain the difference between the eval, integer, and float function. Like my understanding was eval just evaluates everything, when I was trying to read what it does, a lot of people don't seem to like to use it because they claim it's insecure.
Exactly right. Eval is evil. I wish it wasn't in the course materials. Unfortunately, it is. Eval is evil. Never use it. That's my professional opinion. Well, that's not just my professional opinion. That's pretty much everybody's professional opinion is do not use eval ever. If you want to use it for the course, I'm not going to count off because it is shown as an option. But professionally, never, ever use eval. So what we're talking about here is, we could put eval here instead of integer. So what eval will do, it will take whatever that string is and it'll execute it as if it was Python code. That's why it's insecure. So if I just put just the number 10 in there, if I execute that, if I have the string 10, and if I execute that as Python code, then it gives me the number 10. Okay. So in that regards, eval works. I could put the number 10.2 if I type that in as my string. Actually, let's delete some of this and let's show some of this in action. First number, print second number. Let's do the type so you can see what's going on. All right, so we're going to print out the type of the first and second number, right? Actually, let's do 3 of these things so we can see them all 3 at the same time. Third, print the type of third number. There we go. All right, so we're just going to use eval, and then we're going to print out the types of each of those. Okay, so let's enter an integer first. Let's do a floating point number, and then let's just do a string. All right. Well, for one, it crashes. It's crashing on the string, really. Let's take out the string, and then you'll see why it's crashing here in a second. All right. So let's just do the first and second number. So do that, 12, 12.34. You can see it tells me that first number is an int and second number is a float. So on the surface, eval seems like it's pretty good. You don't need to figure out if it's an int or a float. Python will figure it out for you. And if you want to use it for the course, I won't count off, but I'll tell you, if you do this on your job, you're going to get a reprimand. I'll say that. So why is it bad? It really has to do with this third line where it crashed. So let's just do the third line where it's a string. Well, actually, yeah, let's just do the third line. Actually, it can just be the first one. All right, so we have one line here. Whatever I type in, it's going to try to execute it as if it was Python code, right? So if I just type in a number, that's fine. It's an integer, right? So print out the type and print out what it is. There we go, 10. It's an integer and it's 10. Fine. That's a float, and that's the value of it. That crashes. And why is it? What it's trying to do, it's treating that string as if it was Python code. So what you could do in here, technically, you could type out some kind of Python code and it would execute that code. For example, let's print out X. Right now, this is going to fail. Why? Because X is not defined. Python right now does not know what X is. X is a variable, but I haven't said what X is. But what I can do now, I can say here, as part of this eval, I can say X is 1. Well, I'm sorry, I got Python 3 installed. This is how it works in Python 2. But I guess the point I'm trying to get at, though, is that it treats this as Python code and it executes it. So imagine you're running some kind of web server using Python or something, and you have the user type in their username on the web page, right? And so you send that username to your Python code and you do an eval on it, right? Or it doesn't have to be a username. You can have a web page that has the user type in a number. And then if you do an an eval on what they typed in, it's like they're running a command on your web server. So I could type in a command here that deletes your database.
Professor,
Yep.
quick question. So is that like say if we go off the scenario that you're running a web server, could that make it easier for an SQL injection? Like is that why a lot of insecure websites say if like you're running Python, like say if you're running HTML with some Python code in there because it's more flexible. Would that like open up a lot more like doors for an SQL injection?
Absolutely. I mean, this can run anything. So it's not just SQL injection like you're talking about. Like I said, if this was if this presented a web page and this was, say, it was just a web page calculator, and you said type in a number, and they typed in a command to delete the database, then whenever it runs this Python code, it's going to delete your database, right? I mean, maybe you expected the user to type in a number and run the web page appropriately, but if they type in some kind of command, a Windows command, a Linux command, a Python code, whenever you use eval, it will execute that as if it is just a command. So that's why eval is very dangerous, especially if this is coming from the user can never be trusted. Okay. The user can never be trusted to give valid input, really. That's why eval is dangerous, because they could type in anything and then your Python code will just execute whatever they typed in without any kind of checks or anything like that. So that's why I don't like eval. I prefer int. I prefer float. If you use eval, you're not going to get points taken off, but don't ever do it after this class. What should we use if we want to allow the user to input an integer or a float? You need to know ahead of time what you want. If you eval will let you do that, but I just went down the list of reasons not to use eval. You need to know ahead of time what you want the user to input. For example, if I'm asking the user to enter their age, I'm going to expect that to be an integer, right? I expect their age to be an integer. If you wanted to, you could put enter age as an integer, if you want, and that's fine. But it's what you expect it to be. If you're doing like, what's something that would be a float? Enter area of circle, something. I don't know. Of course, that needs to be a float, right? Because the area of a circle isn't always just a whole number, right? So I would expect that to be a float. Now, when you have float, that doesn't mean they can't type in an integer. What do I mean by that? Print first number, print the type of the first number, right? So just disregard what it's asking me to type in. The prompt isn't really important. But I'm going to say what they type in is a float. That means if I type in a float, then it works fine, right? It says the type is float, and that's the value. I can type in this 3.0. That's still a float, and that works fine. First number, The type is a float, and that's the value. What if I type in a whole number? That's okay too. Because let's think about it. Can I convert a whole number into a float? And the answer is yes, I can, because 3 is the same thing as 3.0, right? It makes sense that you can convert like that. Now, you cannot, as I said earlier, you cannot do it the other way. So if I'm saying that's an integer, I can do 3 and that works fine. I can't do this because it doesn't make sense to be able to convert 3.14 into 3. You know, that doesn't make sense. But the other way does make sense. So if you're completely unsure what if they're going to type in an integer or a float, I would use a float there. But if you're absolutely sure it's going to be an integer, then I would leave it as an int. If there's any other questions, go ahead and let me know. I'll excuse me. I'll stand by for a couple more minutes, see if there's any questions. If not, feel free to drop off whenever you want. This session is being recorded. I hope I click record. Yep, it's recording. And I will get it posted on the class announcements so you can go back and review it later.
I was wondering if you would mind if I asked one more question, Professor?
Oh yeah, the question about the methods, or excuse me, about the function.
No, actually, sorry, that was a previous person.
Oh, sorry. Oh, yep, go ahead.
Mine was in regards to the comments. I know in our readings it said that it's acceptable to do single line comments versus end of line comments. I was just wondering, like in your experience, is it also like in the industry acceptable to do both, or do people usually prefer just to have single line comments? Like, does that look cleaner, or is it pretty acceptable to just do both?
My opinion, in most of the places I've been, what I have here is more acceptable. Kind of like the comment on one line and then the code on the next line. The reason being, let's say, I know that I know this isn't code, but let's say that was my code and it was that long, and then I put a comment here. And now if I scroll back to the beginning, where's my comment? Right? I mean, it's there if you scroll over. Or if I make my editor bigger, you know, I can see it. So what you don't want is kind of your comments hidden there off the edge. So it's better to have them on their line, excuse me, on the previous line, on a line by themselves, so that, you know, even if it's off to the side like it is in this example, you know, I don't have to scroll and look for it. It's right there.
Hey, Professor, I got a question.
Yep.
So right now I'm on my Windows machine, but I typically for work and for school I typically use a Linux box, and I see you have Visual Studios. I don't have my Linux box with me, unfortunately. I'm lending it out for a friend because we have a different class tomorrow that she needed it for. But how did you get Visual Studios on your Debian box? I have no, you have Ubuntu. I'm running Debian.
Well, this is Visual Studio Code. Visual Studio Code is different from Visual Studio. So code is multi-platform. It does not have a compiler built into it like normal Visual Studio does. It's a really, really good code editor. And you can set it up to where it does compiling and stuff like that. I don't do that. I compile on the command line. But so Visual Studio Code is different from Visual Studio. So
Okay.
you can install it. I think it's sudo snap install code, something.
I'm running Debian, so it's different. I don't use
Okay.
Snap. I use APT.
Okay, well, yeah. So I'll just do a search for Visual Studio Code, and I'm sure you can get installation instructions for Debian.
Okay.
But yeah, just look for Visual Studio Code, which is different than Visual Studio.
Okay.
All right, I'm gonna stop the recording. If you want to stay on and hear about functions, which is further along in the class, you can go ahead and stay on. I'm going to answer the individual's questions about functions. You don't need to. It's further along in the class, but if you want, you're welcome to stay on for it. But I'm going to cut the recording. I don't want to get that posted and have people confused about stuff further along in the class. But as I said earlier, it's recorded. I will get it posted on the course announcements so you can access it later if you need to.